why we choose an immersed tunnel, what would be the pros, cons, and the myth. So this international webinar is being held as a result of, as being said before, a great collaboration between Civil Engineering College, the Institution of Engineers Indonesia, alumni Teknik Sipil ITB, ALSI ITB, and the MTK BTI. As usual, before we start, let us remind ourselves as Indonesian engineers, our contributions, both individually and organizationally, have significantly contributed to many projects, accomplishment, engineering innovations, and of course, prestigious achievements. These have colored the nation's journey towards becoming a great nation, a nation that is developed, independent, and wealthy. Yeah, I think we are pursuing the same objective as part of the engineering communities. Ladies and gentlemen, respective engineers attending this international webinar, let us elaborate a little bit regarding the immersed tunnels. Immersed tunnels are a competitive alternative to bridges and bored tunnels, particularly advantageous for shallow, soft soil, or seismically active water crossings. This application may involve fabricating tunnel sections on land, floating them to the side, and lowering them into a prepared trench in the seabed. The decision to use an immersed tunnel also depends heavily on specific project site conditions and is often a balance of cost, construction time, as well as the environmental factors. There will be pros and cons discussed in this international webinar, presenting our international speaker, including the opinion of some people saying that this immersed tunnel is a myth. They said immersed tunnels are new, unproven technology. In reality, over 100 immersed tunnels have been constructed worldwide since the early 20th century, with the technology coming from countries like Netherlands, the US, and Japan. Other myth is they said that the immersed tunnel cannot be built in poor ground conditions or earthquake zones. In reality, these infrastructures are highly suitable for soft alluvial soils and can
Mr.
be
Moderator, could you
specifically.
short it up because I have very
Yeah,
limited time.
yeah.
Yeah, please, maybe.
Okay.
Sorry, I'm the middle meeting with my ministry, so if you can
Okay.
speed up a little bit.
Okay, Pak. Yeah, sure.
Yes, sorry.
Yeah. And through this event, let us also report the enthusiasm of our engineering graduates and engineers. They are becoming the PI members. The membership continue to increase. We recorded that we have at least 40% of PI membership today, which make our members around 40,000 civil engineers and overall PI members to be 95,000 members, alongside other 26 engineering disciplines. Yeah. With this total number, significantly will enhance the performance of PLI side by side with a global engineering organization, with global professional organizations such as Engineers Australia with 120,000 members. Hopefully, this momentum, we will improve our professionalism, uphold our professional ethics as professional engineers to pursue to achieve the dream of Golden Indonesia. Yeah. Once again, congratulations to international webinar hosts and organizer who have made this event such a great event, have a great discussion, and contribute to resilient and advanced infrastructure development towards Indonesia Emas 2045. Billahi taufiq wa hidayah. Assalamualaikum warahmatullahi wabarakatuh. Yeah.
Okay.
Thank you so much, Bapak Habibi, for the warm welcome. Next is our privilege to first invite Bapak Abdul Malik Sadat Idris, STMN, Chairman of ALSI, Civil Engineering Alumni Association of the Bandung Institute of Technology, to deliver his welcome address. To Pak Abdul, the floor is yours.
Thank you very much. I think usually we are engineers, yeah. We don't really like a lot of ceremony, but what we want is how actually the solution is coming. First of all, thank you very much to invite me, and as also the planners in the infrastructure. There is a lot of potential of the plan, yeah, ongoing plan on the immersion tunnel in Indonesia, because we are in the island countries, and uh, now we improving our connectivity. And as I mentioned, that the immersion tunnel actually is already proven technology in other countries. So now let's collaborate between international engineers and Indonesian engineers, how actually to prepare the real project in Indonesia condition. So by this collaboration, I think it will speed up the implementation. Before, as I remember, there is one project is being proposed here, but it's still on the, I think, in the preliminary stages. So it's a good time that we actually can go in more detail the job to find a solution and to find viability, and hopefully in the next 2 or 3 years we have our very first project of immersion tunnel in Indonesia. So yeah, once again I congratulate this occasion. Yeah, I'm sorry, I'm very limited time because with my ministry right now. But I will see the conclusion actually, how the strategy of the implementation of the immersion tunnel. For the international speaker, I highly appreciate, and hopefully the collaboration could be continued in the future. Thank you very much.
Thank you, Pak Abdul, for your thoughtful and encouraging remarks. And let us now proceed to the main segment of today's webinar. The segment will be moderated by Dr. Insinyur Alfa Adib Ashidiki, STMSC IPM, Deputy Secretary for the Transportation Sector, Civil Engineering College, the Institution of Engineers Indonesia. To Pak Adib, the floor is yours.
Okay, thank you, Mbak Zakia, Mbak MC. Good afternoon, gentlemen. Assalamualaikum warahmatullahi wabarakatuh. It is the Institute of Engineering College, the Indonesian Tunnel and Underground Construction Society, and the ITB Civil Engineering Alumni, or ALCI-ITB. Thank you for joining us. Before we begin, we would like to sincerely acknowledge and appreciate our partners and sponsors. Our gratitude goes to PT Admix PCI Indonesia, Saman Corporation, Agrinas Daladri, and PT MRT Jakarta for its contribution and partnership in delivering this webinar. Immersed tunnels are underwater road or railings built from large prefabricated sections that are floated out, jenisang, and joined together on the seabed. For cities with busy ports, this method can be practical alternative to high bridges or deep port tunnels. Today's session will explain what a tunnel is and when this method is the right choice compared with a high bridge or a port tunnel. It is my honor to serve as your moderator. We are joined by our distinguished speaker, Mr. Arjan Lutikhoff, from TEC, Tunnel Engineering Consultant, who will share insights on the pro and cons of this relatively new technology. We are also pleased to have representatives from our experts and key institutions. We will provide response and local perspective. Joining the panel are Mr. Lee Kin Ho from Saman Engineering, Korea, and Pak Rian Setiadi from the Indonesian Tunnel and Underground Society. The format will be keynote presentation, short responses from panelists, followed by Q&A. And you also can please write your question in the Zoom chat using your name and institution. We will select them for discussion. Now let me introduce our keynote speaker, Mr. Arjan Lutikholt. Mr. Arjan is a Deputy Managing Director of TEC, Tunnel Engineering Consultant, where he works as tunnel specialist. He graduates from Section University of Applied Science in 2004 and Delft University of Technology in 2007. With this strong regional and practical background, Arjan will share valuable insight on what is immersed tunnel technology. Without further delay, I would like to invite Mr. Arjan to deliver his presentation. Mr. Arjan, are you ready? Is still mute? Yes.
Yes, I'm ready. Can you hear me?
Yes. Okay, Mr. Arjan, the screen is yours.
Okay, I'll try to share my screen.
Yes.
Let's see. Oh,
Okay, we can see your screen.
you can see my screen?
Yes.
This one. Do you see the... No, can you really see my screen?
Yes, I can see your screen. It's okay.
So you see the... because I have two screens, which one do you see?
The page one, but it's closed now.
So this is the right screen.
Yes.
Okay, so I'm not sure you can see my screen because it's not showing.
Your screen is okay. Your screen is okay.
Now it is sharing, I guess.
Yep. Yes, good.
Okay, thank you for inviting me. My name is Arjan Luttegold. I started in 2007 as a structural engineer at Tunnel Engineering Consultants. And in the last 18 years, I have worked on multiple projects. I started on board tunnels in the Netherlands for the North-South line. It's a metro line in Amsterdam. So for the first 2 years, I did some bored tunnels, but then I stepped into the immersed tube tunnels. And I worked on tunnels in the Netherlands, but mainly outside of the Netherlands. So in Sweden, Turkey, in China, in Mexico. I've been to Mexico a couple of times for my first immersed tube tunnel. And in Denmark, of course, for the Fehmarnbelt tunnel, that's an 18 kilometers immersed tube tunnel, which is being constructed right now. And I also have been involved in tunnels just on the land. So that's not an immersed tube or a bored tunnel, but that is just cut and cover tunnels. Today, I will tell you very briefly what is an immersed tube tunnel. And then I will tell why do you choose a bridge and when do you choose a tunnel? And when you choose for a tunnel, when should it be an immersed tube and when should it be a bored tunnel? So I will give some examples of it, and then we will see why for certain projects it is a bridge or why it is a tunnel. I will tell a little bit about the structural design and the foundation, and then I will finish with the immersion operations. So what is an immersed tube tunnel? On the left, you can see a casting basin. So what the idea is that the tunnel elements will be constructed somewhere else in the dry. So on the left, you can see 6 tunnel elements being prefabricated. And once these tunnel elements are finished, the building dock or the casting basin is flooded with water. That is what you see on this picture. And once the casting basin is entirely flooded, then the dike will be removed and the elements can be transported out to the final location. And that is what you see on the right side. This is the final location of the tunnel, and the 6 tunnel elements will be immersed on the bottom of the river. So that is the idea of an immersed tube tunnel. In this graph, you can see the history of immersed tube tunneling. So on the horizontal axis, you see the timeline, and on the vertical axis, the number of tunnels constructed. And more than 100 years ago, the first immersed tube tunnels were constructed in the United States. At that time, that were steel tunnels, and those steel tunnels were filled with unreinforced concrete. And 50 years later, the first immersed tube tunnels came to the Netherlands, and then it has been developed into reinforced concrete immersed tube tunnels. So no steel tunnels anymore, just ordinary reinforced concrete. So in the Netherlands, we now have more than 30 immersed tube tunnels, but most of them have been constructed now. There will be not a lot of new ones. Most of the new tunnels are now being constructed in China and in Hong Kong. Oh. Here you can see a longitudinal section of an immersed tube tunnel. And I will tell you some typical items of an immersed tube tunnel. So as with every tunnel, it starts with an open ramp structure on the left. So there is no roof yet. Then there will be a closed tunnel ramp section, which is not yet being immersed. It's just a construction built between sheet piles excavated, and then you build the tunnel. It's a cut and cover tunnel. And then as soon as you go below the waterline of the river, you can use the immersed tunnel technique. So that's what you see here. You see 1, 2, 3, 4, 5, 6, 7, 8, 9 tunnel elements. They all will be immersed. And then there's a cut and cover section again, a closed section, and the open ramp. And the basic idea is that you stretch the immersed tube tunnel as far as possible into the land. So you try to do the immersed technique as long as possible before you go into the cut and cover section, because it's actually very simple, because the immersed tube tunnel, you can put it in wet conditions. So you excavate the river while it is in a wet condition. And for the cut and cover sections, you need to excavate in the dry, and that's much more expensive than just producing in the wet. The tunnel always goes below the riverbed, just below the riverbed. You don't need to go much lower. And you often see a tunnel protection on top of the tunnel. That is to protect the tunnel for the river current and to protect from any falling anchors. You need to take care of the shipping lane. That's usually the deepest part of the river. There you need to take care of the keel clearance, the dredging tolerances. Between the tunnel elements, there is a joint. We call that the immersion joint. So if there are 9 elements, then you have 10 immersion joints. And inside the tunnel element, there are segment joints. So in a cross-sectional view, this is an example of a non-existing tunnel. You can see traffic tubes, 2 times 3 lanes. There's a central gallery in between. You can use this central gallery for cabling, for electronics, for maintenance. And you can also use it for escape, a safe room. So once there is a fire in a traffic tube, then people can escape to this central gallery and then they are safe. You can also put a train into the tunnel. That is what you can see on the left. And usually it's a rectangular shape. It is being put in a dredged trench, so it is below the riverbed. And after immersion, it is being backfilled with sand and covered with the tunnel protection. And now the most interesting part starts. So when do we choose a bridge and when do we choose a tunnel? And then often we use this picture, and this is quite a famous picture in tunneling world. So you can see a cable-stayed bridge on top. There's the immersed tube tunnel just below the riverbed, and then there is the bored tunnel. So what is the main reason why you should choose for a bridge or a tunnel? Well, that is the shipping traffic. So if you have very large ships coming in, and large ships usually come in when you are close to sea, when there is a big international harbor, then ships are big, and once ships are big, you need a very high bridge. So this bridge can be 40, 50, or even 70 meters high. And once the bridge is so high, you need to have very long approach bridges because you can only go down by 5%. And then you end up with a very long structure, taking a lot of land at the shore sections. And then the structure becomes very expensive because it's so long. So if you compare that to the immersed tube tunnel, that structure can be much shorter because it's just below the riverbed and then it ends as soon as the shore starts. So the structure is shorter and therefore cheaper. And if you look at the bored tunnel, the bored tunnel should be placed deeper. A bored tunnel needs a cover on top. It cannot be just below the riverbed. It needs to be deeper. And when you are deeper, then the tunnel becomes longer. And if it becomes longer, it will be more expensive. But it is, of course, not always the case that the immersed tube tunnel is cheaper. When the crossing becomes very long, then the bored tunnel will become more cost efficient. Because for the bored tunnel, you need to buy a tunnel boring machine, and a tunnel boring machine is very expensive. But if you have a very long tunnel, so if the river is 1, 2, 3 kilometers wide, or you just extend the tunnel, then you still have the same tunnel boring machine. And then every meter longer, it's not that expensive anymore. So what you should remember is that when your tunnel gets longer, the bored tunnel gets cheaper. But when it's just a usual river and it's a short tunnel, then the immersed tube tunnel is most of the times cheaper than a bored tunnel. So if you compare the bridge to the tunnel, what is the advantage of an immersed tube? Well, there is less visual impact and less noise pollution. On the right, you can see two pictures. I think the top one is in Hong Kong, the Stonecutters Bridge, and the bottom one is, I think it is in Shanghai. You can see how much impact the bridge has on the view, on the noise, and on the land. So while it can be a beautiful structure like the top one, it also has quite some impact. Furthermore, the pillars of the cable-stayed bridge, they can interfere with the obstacle limitation zone in an airport. So if you are close to the runway of an airport, these pillars are not allowed. And we know a lot of situations where a bridge has been replaced by a tunnel because of this airport close by. Tunnels also have less hydraulic blockage in the river. The pillars, well, in these two pictures, the pillars are standing outside of the river, so there is no blockage. But most of the times, those pillars are located inside of the river, and then they are blocking the water flow, and sometimes that is not allowed. What is an important benefit of immersed tube tunnels is that a significant portion of the works can be executed with local labor. It's just a simple reinforced concrete structure, and in most countries all over the world, people are able to construct a reinforced concrete box structure because it's not more than that. Only when you need to place these elements on the riverbed, you need to dredge the riverbed, and then some international dredging companies might be required. And also with the placing of these elements, maybe you need a specialist foreign company. But it's only small parts. The biggest chunk of the works is the construction of the concrete box, and that can be done with local labor. Another big benefit is that they are well resistant to earthquakes, and that's not just an immersed tube tunnel, that's also bored tunnels. In general, we can say that structures below the ground, they can better withstand earthquakes than buildings on top of the ground. Whenever there has been an earthquake, then it's a lot of damage to all structures above ground, but not below the ground. Well, there are also disadvantages of an immersed tube tunnel. There is environmental impact due to the dredging works, but on the other hand, whenever there is maintenance dredging in a canal or in a river, you also have environmental impact. So you need to take care of these environmental issues during design, and then most of the times you can take measures. Well, if you compare immersed tubes to bored tunnels, then the first thing, what is different, that's the shape of the cross-section. So the immersed tube is rectangular, and it can much better accommodate the traffic envelope of the traffic. If you have a circular bored tunnel, then there is additional space on top and below of the bored tunnel, and that is just space which will not be used. So the rectangular shape is more economical. Considering the construction planning, a TBM tunnel, a bored tunnel, you always first need to make a very deep start, a cut and cover section, the ramp section. And from that ramp section, you start drilling with your TBM. And only after the final section of the TBM has been finished, you can finalize your tunnel. So it's all construction after each other. The immersed tube tunnel, you can do parallel construction. You can start making your tunnel elements in a casting basin, while at the same time you are making your cut and cover sections. So we have parallel construction, and therefore immersed tube tunnel can be constructed in a shorter time span. Yeah, and the disadvantage of an immersed tube tunnel, they become much more expensive when the tunnel gets longer. So TBMs will be cheaper when they are longer, but it takes much more time once a TBM tunnel becomes longer, because you need to wait for this TBM to finish drilling. I will now walk you through a few examples. This is the Chesapeake Bay crossing, a timber shoal crossing in the United States, in Virginia. It's being constructed in the 1960s. And on the right side, you see a top view, and it's a very, very long bridge section. You can see it's two parallel bridges, but then at a certain point there is made an artificial island, and then there is an immersed tube tunnel and another artificial island. And then it continues with a bridge again. So my question is, why is there an immersed tube tunnel at this section? Actually, it's at two sections. Here is an immersed tube, and there is an immersed tube. So when you first look at this picture, then a shallow bridge is the cheapest option. So that's why most of the connection is being built with a bridge. But behind this crossing, there is the largest military or naval base of the United States, with a lot of marine equipment. And the United States military said, we want free access to the sea, and we don't want a bridge when we go to sea, because a bridge can be very fragile. If if the bridge gets bombed, then our passage to the sea is blocked, and we don't want that. So it's just because of the naval base behind this crossing that there are 2 immersed tube crossings. And also for the Busan Gyeonggi crossing in South Korea, that's also because of a military base that there is a tunnel and not a bridge. So that's the reason why there is a tunnel. And why is this an immersed tube tunnel and not a bored tunnel? Well, this is a traditional or a classic example of why it should be a immersed tube tunnel, because it's very shallow. The soil conditions are very good. It's just soft soil, but not too soft. The soft soil can easily be dredged, so that's not a problem. And at that time, immersed tube tunnels were the only technique which has been used before, and at that time, tunnel boring techniques were not so advanced. So at that time, the immersed tube tunnel was the best solution. And currently, there is being made a second tunnel here. So you can already see in this road that there is a provision made for another connection here. And at the moment, they are making a TBM tunnel. So there is one immersed tube tunnel on the left, and on the right side, they are making a bored tunnel. So why don't they do a immersed tube again? Well, that is because it's very close to the existing immersed tube. So they don't want to dredge a trench for the new immersed tunnel, because there would be too much impact on the previous immersed tunnel. And the second reason is that the tunnel boring technique has advanced a lot. And now they can also, with this tunnel boring, they can also make this connection. And that is what they are doing right now. And actually, it has been delayed a lot because the tunnel boring machine drilled against an anchor, and they had to remove that anchor in front of the tunnel boring machine. This is a tunnel currently being constructed in Canada, in Vancouver. It's next to the old George Massey tunnel. There will be a new tunnel, the Fraser River tunnel. And on the left side, you see a picture of a tunnel, and on the right side, you see a bridge. So why did they now finally choose for a tunnel? Well, the tunnel is only slightly cheaper, so that's one of the reasons. But the government said this bridge has too much of a impact on the visual impact. There's too much noise, and the lighting of the bridge has also too much impact. And the approach bridge would have too much impact. But it's very close. It's also politics when one wants a tunnel or one wants a bridge. Finally, it has been decided to do a tunnel. This is the Maas Delta tunnel in the Netherlands. It is close to Rotterdam. It is finished 2 years ago. You can see an aerial picture on the right top. And why has a tunnel been chosen and not a bridge? Well, this is close to Rotterdam. It's one of the largest ports in the world, and very, very big ships are entering the harbor. So when big ships need to cross here, and you would have constructed a bridge, then you would have you would have really a big bridge and with a lot of impact. So that's why a tunnel has been chosen. And then the next question is, why is it an immersed tube tunnel and not a bored tunnel? Well, you can see on the longitudinal profile on the bottom that the tunnel is very deep because this river is very deep. It's 15 meters, I guess. And but the tunnel can go slightly beneath the riverbed and then go up very quickly again. And on the left top picture, you can see the south side of the tunnel, and there's a big, there are other cable tunnels located, and they could not be removed. So if there was a bored tunnel being made, then the bored tunnel would be deeper, and then the bored tunnel would not be able to be on the surface level before it had to cross these cable crossings. So because this tunnel, the immersed tube tunnel could be much shorter, it was the only option here. This is the Hong Kong-Zhuhai-Macau bridge link. This connects Hong Kong to China. And it's a very long bridge, but at a small portion, there is a tunnel. So what is the reason that there is a tunnel? Well, that's because of the airport of Hong Kong. And this tunnel is just directly in the path where the airplanes come down to the runway. So no pillars were allowed. So that's the reason that a tunnel has been chosen there. And why is it an immersed tube tunnel? Yeah, it's because of the bored tunnel had to go much deeper. And if you do a bored tunnel and you go deeper, then these artificial islands would have been much longer as well. So in the end, the immersed tube tunnel was cheaper than the bored tunnel. This is another nice example of the Western Harbour Tunnel in Australia, Sydney. It's a tunnel going through the Sydney Harbour. And on the right top, you can see a cross-section, a longitudinal view with the 4 possible options of tunnels. So there is sandstone. Sydney is all sandstone, except at the harbour. The water is filled there with soft sediments, with clay and harbour sediments, soft deposits. And usually in Sydney, they construct with a roadheader. So they just excavate the sandstone. Very easy. It's actually very easy and cheap. But at this section, to cross the Sydney Harbour, the roadheader had to go very deep because there are all cracks in the sandstone. And if there are cracks in the sandstone, then water would come into the tunnel while excavating. So a roadheader, to do this with a roadheader, it had to go very deep. And when it goes very deep, you afterwards need to go up, and then the inclination would become too much. So only 5% is allowed, but that had to go up to 6, 7, 8%. So the roadheader was no option. And then you have the TBM option, and you have some different types of tunnel boring machines, and they can go, well, just beneath, they can go slightly higher. And then you have the immersed tube tunnel, and it can go even higher. An immersed tube tunnel has no problems with very soft soil conditions. Well, in the end, designs has been made for an immersed tube and a TBM tunnel, and the winning contractor proposed to do this with a bored tunnel. So currently they are drilling this section. I hope this gave some ideas. When do you choose for a bridge and when do you choose for a tunnel? And now I will tell some about the structural design of a immersed tube tunnel. So on the left top, you see a cross section, and that is a reinforced concrete section. This is the most traditional or the most common way immersed tubes are made. Most of them, I think 90% of all immersed tube tunnels are made with reinforced concrete. It's been made in sections of 20 or 25 meters, and then 5, 6, 7, or 8 of these sections are put together, and then you have one element. So this is what can be constructed in every country. It's not heavily reinforced, or it's just ordinary reinforced concrete. And once you need, when you go deeper rivers, or you have more traffic lanes into your tunnel, then the forces on the roof and the floor become larger, and then sometimes you need to add transverse post-tensioning. Well, then the structure becomes a little bit more complex. So a few of these tunnels have been constructed like this. And then in China and Japan, they are making, what's that? Is that me?
Yes, you can
What's
continue.
the noise? It is not me.
Yes, maybe someone. Okay,
Yeah, okay.
you can continue.
No problem. So, and in China and Japan, they are making steel tunnels as well, and that is can be used when you go very deep or when the tunnel becomes very wide. Then the forces become too large to take with reinforced concrete, and then you go to steel sandwich tunnels, and then they are made of steel. So the inside and the outside is steel plates connected with steel webs, and they are filled with self-compacting unreinforced concrete. And they can take higher forces than reinforced concrete. And then you have a combination of reinforced concrete and steel, and that is on the bottom. And you can use that to, when you want to produce the steel shell somewhere else, and then float it close to the tunnel site, and then you can finish it with the reinforced concrete. But that has not been used a lot. So in the longitudinal direction, there are two options as well. You can do a monolithic tunnel, or you can do a segmented tunnel. So a monolithic one is just reinforcement all along the entire element, and then you have joints, but that's only a cast joint. And then on the bottom you see a segmented tunnel, and that's made up of sections of 25 meters, and then there is a joint. Reinforcement is not continuous there. There is a shear key in between to transfer the shear forces. And because the reinforcement is not continuous, rotations can occur. And that can be very beneficial when you have the soft soils. Then the tunnel elements can very closely follow the settlements of the soil without that a lot of high forces come into your structure. It is all being accommodated in the joints. Most of the tunnels have been constructed like a segmented tunnel. Well, the most famous part is, of course, the immersion joint. So between the elements, there will be a rubber gasket, a rubber seal. You can see it on the right top. It's one piece, and you mount it at the end of the tunnel element on a steel frame. And then you position, during immersion, you position the newest element against the previous element. And then the rubber seal makes sure that it is watertight. And then the water in between the two elements is pushed out. And because of the water pressure on the other side, a very, very firm connection is being made. So that's the idea of connecting immersed tube elements. So once the water inside of this chamber has been released, when it is out, the GINA is compressed and no water can go in anymore. So on the right side, you see a detail of the compressed GINA. You can see it here. But after immersion, and when you are going to finish the tunnel from the inside, you are placing a secondary water stop. That's the omega profile. You can see it here. It has the shape of an omega. And that is just a secondary water barrier. So it's just to be sure that in case this GINA starts to leak, then there is a second water barrier stopping the water. But from all the tunnels we have seen in the past, there's never leakage through the GINA profile. It is just being compressed so much that there is no leakage. Now, on these pictures, you can see the GINA profile. So on the right side, it is mounted onto the steel frame, and on the left side, you see the other end of the tunnel element. So there is no GINA seal on this side, and the GINA seal will be pressed on this steel. So on the right top picture, you see an uncompressed GINA profile, and on the right bottom, you see the compressed GINA profile. So this secondary water barrier, I found two pictures of it. So this is the Omega profile being mounted on the wall. Here is the shear key. So every 25 meters, there is a shear key. And these are transferring the vertical shear forces through the tunnel. This is a sketch of the reinforcement of such a shear key. Well, the immersion joint, the GINA profile, that the GINA profile ensures water tightness at the immersion joint. At the segment joint, we have other water stops. So that is on the right top, you can see a water stop, and that is being poured into the concrete between two casts to make sure that there is no water leakage at the segment joints. And on the outside, there's another rubber profile, and that makes sure that no sand will go into the joint, because when, for example, the tunnel cools in the winter time, then the elements will become a little bit shorter, and then a gap exists in this joint, and then sand is able to go in. But by putting a rubber profile there, sand is not able to come into the joint. And then you need a closure joint. So when you have put all the elements on the bottom, then there is a final section, the final 1.5 meter, you still need to close. And that is what we call the closure joint. And usually it is a wet closure joint. So on the left bottom, you can see this last remaining 1.5 meters. And you put two concrete wedges in, because once you take out the water inside of a joint, then the normal force will be released, and then you need a wedge to prevent two tunnel elements coming closer to each other. And once you have this wedge positioned, you close it off by a steel formwork. It is being placed by divers. And then afterwards, the water is being extracted, and you can finish the floor, the walls, and the roof of your tunnel, and then a complete watertight tunnel has been created. You can also make a dry closure joint. That's what you can see on the top. Then you can see on the left top the final tunnel element, and then you close it off with temporary concrete plates to seal it off from the river. And then you take out the water from the cut and cover section, and then you can finish your tunnel from there. And that's what we call a dry closure joint. And then there are also V-shaped solutions, so that the final piece will be closed with a very small element, the final piece, and it fits just in between the two last elements because of its V shape. When we look at the foundation, there are two options. The top one is used a lot in the Netherlands. I think it's being used the most worldwide, and that is by sand flowing. So after immersion, the tunnel is founded on temporary supports, and then you close the gap between the bottom of the river and the tunnel element with sand. So there are pipes going through the tunnel element, and you pump sand through it, and then sand is flowing beneath your tunnel, and then you have a perfect foundation. Another option is to put a gravel bed before installing the tunnel elements, and then put the tunnel element on top of this gravel bed. Here you can see a pontoon with a fall pipe, and this fall pipe moves over the bottom, and then it is producing the gravel bed. Here you can see it in a schematic picture. It's a bit different. It's a jack-up system with a fall pipe, and this fall pipe is grading over the bottom to prepare the foundation for the tunnel. Well, sometimes ground improvement is required. I told you immersed tube tunnels can be used in very soft soil conditions. So why do you need soil improvement? Well, you don't need soil improvement because the soil is weak. You need soil improvement when you have differences in soil conditions. So here you can see that the gray part, that is a rock material with soft deposits in the river. And once there is the transition from the rock conditions to the soft conditions, you need to smoothen the transition, and you do that with soil improvement. So only at the regions where you transit to two different soil systems, there you can need soil improvement. And soil improvement can be with stone columns or cement deep mixing or sand compaction piles. This is a longitudinal view of the Sydney Harbour Tunnel design. The orange line, that is the top of the brown line, that is the top of the sandstone. So the tunnel is founded for the crater part in the sandstone, but at the right side there is soft deposits. So both are fine, but you need soil improvement at the location where you transit from the sandstone to the soft deposits. This is a more exotic option. You can put your tunnel on piles. This is the design for a tunnel in Turkey. And when you put the tunnel on piles, then it can be much shallower and therefore shorter and cheaper. But of course, it is blocking the river flow a lot, so it cannot be used in rivers where there is a lot of water flow. I think I have a little less than 15 minutes. In the last 15 minutes, I want to show you about the immersion operation. So these tunnel elements need to be placed on the riverbed, and what is required for that operation. Well, first we need a location where we construct the tunnel elements. So at the left top you see a casting basin. That is a custom-made location close to the river where you can make these concrete boxes just in the dry. And once these structures are finished, you fill up the casting basin with water, then you remove the dike and you can transport the tunnel elements to the final location. And such a casting basin can be used more often. So you can do, in the Netherlands, we have one casting basin and it has been used for 10 tunnels or so. And on the right top, you can see another example that's just one very small tunnel element, and that is being constructed in the ramp section. So first you excavate the ramp, and then you produce your tunnel element, and then in 2 days, you take out the tunnel element and you put it into the river, immerse it, and then afterwards construct your ramp sections. On the right bottom, you see a ship dock. You can also go to a shipping yard, and there you can ask to use one of those docks, and there you can construct your tunnel elements. And on the left bottom, you see the factory in China, close to Hong Kong, and there is a factory producing the tunnel elements. Here you can see that it is pushing out 2 tunnel elements, and then there's a floating gate, and this floating gate can close the basin, and then water is being pumped in this basin, and then the 2 tunnel elements just coming out of the factory can be moved to the deeper part of the basin, and then the water is being taken out and the tunnel elements can go outside. In Denmark, they also have a factory. So this is a picture, I think 1 year ago, where 5 production lines are producing 90 tunnel elements for the 18-kilometer long Fehmarnbelt tunnel. Here on the right side, you see the casting basin in the Netherlands. So there is 6 tunnel elements being produced. At the left bottom, you see the casting basin for the Sydney tunnel. And the left top, I don't remember which one it is. Here you see a situation where the tunnel element is being produced at the ramp sections. Another option is to make the tunnel elements at the factory at the key wall and then push it on a semi-sub. And here you see examples of a tunnel element being casted in a dry dock. When you have finished your tunnel elements in the casting basin, you need to close the ends of the tunnel, or otherwise water would come in, and that can be done with concrete bulkheads. You see that on the left, or with steel bulkheads. You can see it on the right. Longitudinal pre-stress is required to transport the tunnel elements. Inside of the tunnel, there are ballast tanks. You need those ballast tanks during immersion. So water is being pumped into these ballast tanks inside of the tunnel element. And once water goes into the elements becomes more heavy, and then they move down to the bottom of the river. Here you can see the GINA profile again. And for positioning, you need a survey tower. You can see it on the right. And on top of this survey tower, there are GPS devices mounted. And on the left side, you see the access shaft. You can enter your tunnel element through this shaft. Well, that is only required when something breaks or you want to check some stuff. Usually no people go in. There's also GPS stuff on top, so you can monitor the exact position of the tunnel element. Tugboats are required to tug the element from the casting basin to the final location. Well, usually the tunnel is being constructed in a port area, and in a port area always tugboats are present, so that's not a problem. Here you can see tugboats again. A pontoon is used to control the vertical position of the tunnel element. So we have lifting lugs here. And these lifting lugs are connected to the catamaran, and they control the vertical position. When you are using a sand flow foundation, you need to put the tunnel element on a temporary support. So you can see here it's a kind of a jack coming out of the bottom of a tunnel element, and they are supported on a concrete plate on the bottom of the river. And on the other side, the tunnel element is connected to the previous tunnel element. And that is the temporary support. Once the element is on the right position, the area between the tunnel bottom and the tunnel element is being filled with sand by sand flowing. To make sure that the tunnel is correctly positioned to the previous element, there is a pen, and this pen will be catched by the catch. So you can see a V shape, and then this pen moves into this V shape while you go down with the element, and then it will make sure that a tolerance of 2.5 centimeters occurs. So the tunnel element can be positioned within 2.5 centimeters. And during immersion, you have a screen with the exact location and data of your tunnel element. This is a plan view of a tunnel in Mexico just before immersion starts. On the right bottom, you can see the casting basin, and one element is being prepared for transport. The final tunnel is located in this area, and a crab is doing the final works. There's a small hopper cleaning the trench. So once the trench is being dredged, sedimentation is entering the trench again, and just before immersion, it is being cleaned by a small hopper. Then you can see a pontoon here. This is the gravel bed pontoon. It's doing the gravel bed. You can see the catamarans being positioned on the left here, and some tugboats here. So that's all the marine equipment used to take out the tunnel element and put it on the bottom. You also can see a cutter suction dredger here, and that has been used to remove the dike between the river and the casting basin. So that is my presentation. I want to thank you, and I give it back to you.
Okay, thank you. Thank you very much, Mr. Arjan, for that clear and insightful presentation. Mr. Arjan already explained what is an immersed tunnel, when a bridge and when a tunnel, and when immersed tunnel and when board and structural design and foundation, and also immersion operation. Next, we invite our panels to share their views, and after that, we will open to the floor for questions. Ladies and gentlemen, please continue to submit your question in the chat box. For the first panels, Mr. Lee Kin Ho from Saman Engineering. Mr. Lee, are you ready? From Saman Engineering, Mr. Lee. Can you unmute, Mr. Lee?
Yeah. Can you hear me?
Yes, yes.
Yes. I'm very delighted to speaking on the topic of the emergent tunnels as a panelist at the seminar. I want to talk to why the Indonesian government is considering an emergent tunnel in Balikpapan. I heard Indonesia is seriously considering an immersed tunnel for its new capital project, Ikn Nusantara. I think the biggest reason is the environmental protection. Balikpapan Bay is extremely sensitive, talking about mangrove forest, marine habitats, and species like the special monkey, Proboscis, that only lives in this region. If a big bridge were built across the bay, the construction alone would cause major disturbance to these ecosystems. But with an emergent tunnel, most of the work happens on the water or away from the natural habitat. So the overall impact is much lower. The second reason is the preserving the landscape. IKN aims to be a nature-friendly capital, and building a huge sea bridge would completely change the skyline of the bay. It would alter the view and the coastline and even the water flow. An emergent tunnel, on the other hand, stay hidden beneath the seabed, meaning the surface of the water and the surrounding landscape remains almost untouched. That fits perfectly with the vision Indonesia has for its new capital. Another important point is minimizing the interference with the shipping. Balikpapan Bay is used by many vessels, including cargo ships, and bridge construction could easily disrupt this route. Large bodies, cranes, and temporary platforms would interfere with the navigation. But with an immersed tunnel, the construction processes is more controlled and causes far fewer issues for maritime traffic. Next, I want to mention the weather and sea conditions. The region experiences strong winds, waves, and changing currents throughout the year. These conditions can seriously delay or complicate bridge construction. An emergent tunnel is much less affected by weather because most of the key work happens below the water surface, makes the overall project safer and more predictable. And finally, there is the fact that the technology is already proven worldwide. Countries like Korea, Denmark, and then Netherlands have built emergent tunnel very successfully. So for Indonesia, it's not an experimental approach. It's adapting a well-established method with a lot of international experience to back it up. That's all. Thanks for listening. And I hope this helped you get a clear picture of what immersed tunnel are all about. Thank you.
Thank you, Mr. Lee. Mr. Arjan, before you reply, maybe I will go to the second panels. Actually, the point from Saman Corporation is how sustainable is these immersed tunnels, because the Balikpapan Bay in IKN is a forestry conservation. Okay, I will go to the second panel. Pak Rian, are you ready, Pak Rian, from Indonesian Tunnel Society?
Yeah, thank you very much, Pak. Good afternoon, everyone. My name is Rian Setiadi. I'm a board member of the MTK BTI, which is the Indonesian Tunnel of the Association. I also work as a senior engineer in Arab Indonesia. I think Arab also working with the TIC in the Fahmenbert Tower, Fahmenbert Immersed Tunnel. First, I would like to apologize. Actually, Bu Weni is the one who's supposed to be a panelist in the seminar. However, there are urgent meeting of the Bu Weni with the minister, so I jump in here as a panelist to replace Bu Weni. So I think I just going to be straightforward for the question, so we can open up the discussion. Thank you very much, Mr. Arjan, for the very good presentation and then very clear, so it can be enhance our knowledge about immersed tunnel. The first question from me for the discussion is actually quite similar with Mr. Lee, which is the environmental impact of the immersed tunnel, especially for the dredging. So when we talk about immersed tunnel, one of the most frequently discussed topic is the environmental impact, especially causing of the dredging during construction. Given this concern, maybe Mr. Arjan can share the experience or knowledge about what is the best practice or recent innovation are available to minimize this ecological disturbance for the dredging from the dredging work, especially in the sensitive marine and river environment. I think the second question that if have a time, we can discuss from Mr. Arjan, is as explained by a keynote speaker that immersed tunnel is very depend on the complex joint system, such as Gina gasket, Omega seal, Cirque, and segment joint. Based on your experience or knowledge, what is the most common durability issue that arise with this joint over the lifespan of the immersed tunnel? How are these challenges addressed in the board design phase and ongoing maintenance planning? I think that's all from me for now. I give it to moderator first, maybe for the discussion.
Okay, thank you, Pak Rian. Mr. Arjan, we have two questions actually from two panelists. It's related to the sustainability of this immersed tunnel. Maybe can you have any comment or response?
Yes, everything has impact on the environment. The immersed tube has especially impact on the environment during dredging. By the dredging works, the turbidity in the water increases. But if you look at this Icaena, for example, this river has a lot of natural sand flow or sedimentation already. So I think the impact of dredging works on the turbidity is you cannot see it in that river because it is already there's already a lot of sand in the water. It's also noise for the fish around the dredging works. For some tunnels, we did not dredge into the breeding seasons. We had one tunnel where it was a salmon area, so 2 times a year the salmon fish came along. So we did not dredge during that period. So there are some measures to take to just minimize impact by dredging. And I think what you said as well, it's you can do the construction of the tunnel elements somewhere else. So you have the impact somewhere else at the industrial area. So that helps a lot to reduce the environmental impact. And after immersion, you put the riverbed back. So you put soil in the trench again. You protect it by stones, and then the existing or the previous riverbed can be restored again. So you minimize impact in that way.
And second question about the durability of the part of the tunnel.
Yeah, so there are rubber seals in between the joints, and rubber seals deteriorate, but they deteriorate because of sunlight, and there is no sunlight in the tunnel, so we never have issues with the rubber seals there. But the issues who do occur is by bad execution, when you do not properly place those rubber seals into the cast joints, and then some leakages can occur after installation. So, but all tunnels leak, bore tunnels leak as well. Cannon cover tunnels leak, and immersed tube tunnels, they are all leaking. So at the lowest part of the tunnel, there is a pump sump to take out the water because of the leakage. But what is important is that you probably execute the concreting works, but it's quite easy works, so that can be done. And what we see we do a lot of renovation on existing tunnels. The renovation works are mainly because of ventilation needs to be replaced. We have new lighting systems, we have new detection systems for fire, we have new regulations on safety. So that's why we need to change things in tunnels, but it's minor things changing on the concrete or on the joints. What we do see is some corrosion on the Gina is mounted on a steel frame at the end of the tunnel element, and we sometimes see some corrosion of those steel end frames, because in the Netherlands during winter time, salt is being put on the road to prevent ice from building up. So it's melting the ice, so that the traffic can go safe through the tunnel. And this salt is very aggressive, and that is attacking our steel end frames. So that's actually what we see in existing tunnels.
Okay. Any other response from Pak Rian?
That's not from me. I think the one
Okay.
that Pak Aran mentioned is already very clear. Thank you for the explanation.
Okay, I will invite for the other participant, other audience. You can raise hand if you have any question or discussion to Pak Aran from the audience. You can raise hand, or you can ask in bahasa. Maybe we will translate it. From the audience? Any raise hand? Or we will wait for the audience to raise hand. Do you still have any question, Pak Rian?
I have, but it seems like there are some questions that posted in the chat. Maybe I
Okay.
just mention it. Yeah. One
Okay.
is from Mr. Rahmat Yusuf. The question is, which is more advantageous in terms of the structure and stability between monolithic tunnel and segment tunnel? If using segment tunnel, how are they connected? I think some has been discussed with Mr. Aran, but if Mr. Aran have any feedback regarding this question.
Yeah, so segmented tunnels, they are segmented. Every 25 meters there is a joint. And during transportation, there is a longitudinal pre-stress through the entire tunnel element, and that is holding together the segments. And after immersion, these post-tensioning cables, they are being cut at the location of the joint, and then the elements can start rotating. And because of this rotating, it can follow settlements very good, and therefore no forces occur in the tunnel. And when there are no forces in longitudinal direction, no cracks can occur. So the 25-meter sections are very well conserved. It's no cracks, so no water leakage. But then at the joint, you have rotations. So you have to have proper water stops to make sure that no leakage occurs in those joints. And then they are connected just with the shear key to transfer the horizontal and vertical shear forces. And rotations can occur, and then sometimes a gap occurs, but the water stop is there to prevent water from coming in.
So which one is better, the segmented or the monolithic tunnels?
When you have a lot of settlements, segmented is better. But when you have earthquake zones, then you want to, then you have different forces on the tunnel, and then we try to do a monolithic tunnel and then a little bit shorter elements, and then they are being stressed with the pre-stress as well, but then they are not cut at the joints, and then you have a very strong tunnel elements where you only have rotations at the immersion joints. But there's not too big of a difference between monolithic or segmented tunnels.
So which one is more difficult in terms of the method construction method?
It's different it's not really different. It's for the segmented, you need segment keys every 25 meters, so you need a bit more complex reinforcement fixing. But yeah, that's to do. So
Okay,
I would say
maybe
the
I will.
segment is a bit more complex, yes.
Maybe I will read the question from the Zoom box. In the chat box, question is, during the installation and setting of the segmental element in the time of concrete casting, what is the method used to safeguard against the risk of water ingress when the element is floated? Thank you.
Yeah, so you make two bulkheads at the ends of the tunnel element, and that is preventing water from coming in. And when the tunnel element is floating, the water pressure is very low. So the tunnel element is 10 meters high. So at the bottom, there's only a 10-meter water pressure. But if you have a river of 15 meters deep, then the bottom of the tunnel is at minus 30 meters, and then the water pressure is much higher. So once the element is floating, you can check if your tunnel is really watertight. But it's not, when it's floating, it's not really an issue. The water pressures are very low.
Okay, so we have someone, Pak Dwisman Wijaya, you raise hand. Maybe you can ask your question directly. Pak.
Mungkin saya dalam bahasa Indonesia saja, Pak Moderator ya.
Oke.
Baik, terkait immerse tunnel tadi, seperti yang disampaikan dari Saman Corporation, ada isu terkait masalah lingkungan, baik masalah pesut yang di daerah sana ketika dredging, termasuk juga daerah bakau yang cukup banyak daerah di sana gitu. Makanya kemarin waktu mereka tim EMS itu, saya menawarkan opsi selain tunnel ada juga metode dengan jembatan. Selain itu juga ada permasalahan isu terkait masalah during construction-nya itu yang tunnelnya ketika dikonstruksikan butuh stok yard yang banyak ya. Stok yard yang banyak, kalau lokasinya sama dengan yang kemarin di FS, itu akan membuka banyak pembukaan terkait hutan dan bakau yang terkena. Mungkin itu bisa dijelaskan lebih lanjut dari teman-teman dari Mr. Aran. Terima kasih.
Oke, terima kasih, Pak. Thank you, Mr. Aran. The question is related to the issues in IKN Balikpapan, the issues with mangrove and fishery. And then the second question is, during the construction, it needs a large area of stockyard. So do you have comment about this?
Yeah, in IKN you have the mangrove area that has to be removed at the part where the tunnel goes from the river to the land. You need to remove the mangrove. It will have impact. And after tunnel construction, you need to put the mangrove back and restore the entire river embankment. And you need to base your environmental impact assessment on that. That's how it is. And the second question is, you need a large land plot. Yes, somewhere you need an area to produce these tunnel elements. But we've also produced these tunnel elements on a quay wall. So then it's just a quay used for shipping to take off the bulk cargo. But you can also construct your tunnel elements there, or the other way around. We've done that also in the past. We have made a casting basin for the tunnel elements, and then once the tunnel construction was finished, the casting basin was transformed into a new terminal for ships. But you are free to choose this location. It can be very far away.
Oh, okay. So it is possible to we prefabricated the element in Java, and then we ship it using the ponton to the IKN area. Is that possible?
Yeah, I think the tunnel element can float by itself. So you can tow it with tugboats from Java to Balikpapan. You can also make it in Korea, or you can make it in China or in the Netherlands. I don't think you're going to make it in the Netherlands. It's you can make it in Java and then tow it overseas to IKN indeed. Yes.
Okay, so basically we don't need that much large area to stock that yet.
Yeah, you need area for the embankments. So for the ramp sections, there of course you need to construct your tunnels, your cut and cover section. But you also are connecting the road, so yeah, there will be impact. Yes.
Okay, we have another question. The second question from the chat box. Are there any difficulties in terms of logistics for embankment used during construction?
Typically, we use sheet piles, and inside those sheet piles, we make the construction pit and the cut and cover sections. And there, once the tunnel is, I think we have 2 rows of sheet piles because it needs to connect to the immersed tunnel elements. And there we have some kind of a special facing in the construction pit, but that's the only thing which is different compared to a usual construction pit for a cut and cover tunnel. And whenever I do a new presentation, I will put a picture in it, I think, on how this cut and cover section transits to the immersed tunnel section.
Okay.
Boleh menambahkan lagi, Pak? Tadi kalau Pak Aran bilang kan dia bisa dari konstruk dari luar dibawa ke lokasi ya. Cuman
Betul.
untuk menuju lokasi yang dituju sekarang yang direncanakan itu akan melewati jembatan kayak jembatan Pulau Balang ya. Itu ada tinggi safety-nya yang harus dilewati. Saya nggak tahu nih tunnel bisa apa enggak. Tapi untuk lebarnya mungkin lebih, kalau lebarnya sampai bikinnya nanti sampai kereta itu yang agak riskan di jembatan yang akan dilewatinya gitu. Mungkin itu Pak.
Oke. So, kayaknya kalau kapal bisa lewat harusnya itu aman juga karena lebar kapal mungkin lebih lebar ya. Okay, Mr. Aran, the audience tell us that there are Pulau Balang Bridge that should be crossed if we need to transport that tunnel element. Okay, maybe we go to another question. Okay, this one. As we know that Indonesia is a country in a high seismic activity. Based on your experience, can you share your project experience immersed tunnel in a country with high seismic activity?
Yeah, my first immersed tunnel project was in Mexico, in Coatzacoalcos. That was a seismic area as well. There we made monolithic tunnel elements. And in the end, you end up with some bigger GINA profiles and shorter tunnel elements. So if you have shorter tunnel elements and you have a larger rubber profile, then you can absorb the displacements from the earthquake much better. So when you have a high seismicity area, then your tunnel design will change slightly, and you will see it in the length of the elements and the rubber seals used. And those tunnels have been used in seismic areas before. In San Francisco, there is a immersed tube tunnel. In Vancouver, a second one is being constructed at the moment. Mexico, so that's just seismic areas. I think it's more difficult to make a bridge able to take the seismic than a tunnel.
Oh, okay. So the critical point is the GINA and omega section.
Yeah.
Related to the seismic activity, right?
Yes.
Okay. Is it which country can produce that element, the GINA and omega and shear and the locking element? Is it difficult to produce?
The GINA profiles are being produced by 2 or 3 companies. So that's in the Netherlands, there's a company, and in China, there's one, and I think in Japan or Korea, there's one as well. That's the GINA profile, the omega profile, and the other water stops are being produced everywhere in the world. That's just ordinary water stops. And the shear keys, that's from concrete. That's just by the local labor.
Okay, I see. Okay, we still have question from the chat box. How should the operation of tunnel structures be planned? be planned, considering the critical importance of maintenance management for building located in the extreme environments. Additionally, since tunnels must be operated in a way that supports the restoration of the surrounding ecosystem to its original condition after constructions, what management approach is required to ensure that maintenance and long-term upkeep are consistently carried out? Okay.
Yeah, so it's about maintenance. I think you have two things. There's the operations of the tunnel, so there should be a control center where people are watching what is happening in the tunnel. So if there is a fire, there needs to be a alarm, and somebody needs to take control of that. So that's the control center, and then there is the maintenance. So yeah, you should probably properly maintain the tunnel, just like you maintain a bridge. So a steel bridge should be coated every once a few years. And the tunnel shall be inspected as well and maintained. Usually during the design time, we make an operation and maintenance manual to explain all the things you need to maintain and how that should be implemented. Usually there is a time schedule. So every year you do these kinds of inspections. Every 5 years you do this. Every few years you change this, and every 10 years or 20 years you replace like the ventilation system.
Compared to the bridge maintenance, how difficult or how expensive is this immersed tunnels maintenance?
I think the maintenance is cheaper,
Cheaper?
but you have more operations. So there's people in the control building watching the traffic in the tunnel. So that's more than in a bridge. But the tunnel itself, it's the concrete is less maintenance than when you have steel being attacked by the weather.
Okay. Okay, next we have question in chat box. Given the need for continuous maintenance management in tunnel structures, especially those located in extreme environments, how is the operational funding for such facilities typically secured? Is it by financing like a toll road, or how is typically the funding for the maintenance and operation?
Yeah, that's dependent on the owner. So in Indonesia, I don't know who will be the owner. It will be the government. So they need to make sure to put it in their budget. I think it is being controlled by the road authority.
Okay. How expensive is the maintenance compared to the initial cost of constructing the tunnels? Is it 10% per year or 1% per year?
I don't know.
Oh,
I don't know.
okay. Okay, do we still have any question from the audience? Pak Rian or from Saman?
Okay, maybe one question for me. In terms of the sustainability again, especially during construction or over their operational lifetime. Do you know any emerging material or method that can further reduce the environmental impact? Like example, in the board segmental tunnel, we currently explore the concrete without the rebar using fiber concrete. Is there any technology that can be you see that can be applicable in the future, especially considering this carbon impact and etc.? Maybe you can share it to us.
Yeah, that's a good question. We are also looking for optimizing the carbon output of our designs and the construction. I think most of the work is being done on the concrete mix, but it's not specially for tunnels. It's just for bridges, for buildings, for houses as well. What we are looking to is into the power used during operations. So there's a lot of power going into the ventilation and into the light. And we are now currently experimenting with a tunnel where the light comes from a glass fiber. So the sunlight is being catched at the entrance of the tunnel, and then with glass fiber cables it goes through the tunnel, and then it is lighting our tunnel. So I think that's a very good development, because when it's dark, you need not too much light in your tunnel, because your eyes are used to the darkness, and then you don't need too much light. And when it's daylight, you go from very bright day into a dark tunnel. So during day, you need most light into your tunnel. So then these glass fiber cables, they work very well, because then they catch a lot of light and then they can do it into your tunnel. We're also experimenting in one tunnel with capturing the dust from cars, so the nitrogen and the emissions from the cars. We have cladding on the side of the wall, and they are absorbing these pollution. So that's being experimented with. Yeah, that's two examples.
Thank you.
Okay, we have question from design to immersion process, which technical risks are most often underestimated, and how should project owners anticipate them? The risks from design to construction and immersion. What is the risk that most underestimated?
Yeah, I think it's the soil, so the soil conditions. I think it's most of the time soil investigations come in very late, and then then you're almost finished with your design, and then new soil information comes in. So I think it's always wise to do as much as soil investigations as you can do as soon as possible.
Okay, do we still have any question? Okay, because it's already the time. Maybe well, since the time is up, now I move to closing. On behalf to organizers, we extend our appreciation to Mr. Arjan. Thank you. And our partners to Adimix PCI Indonesia, Saman Corporation, Agrinas Daladri, and PT MET Jakarta, and all the participants. We hope today's discussion will encourage stronger collaboration and more innovative solutions for tunnels and transport infrastructure in Indonesia. And now I give back to the MC, the host, Ms. Zakia, to continue to the next agenda.
Okay, thank you, Pak Adib, speakers, and all panelists for moderating the discussion and Q&A session. So as we approach the conclusion of today's webinar, we would like to invite the Vice Chairman for the Transportation Civil Engineering College, the Institution of Engineers Indonesia, Insinyur Dedi Gunawan, STMSC, to deliver the closing remarks. To Pak Dedi, with great respect, we invite you to share your closing reflection.
Okay, thank you, Pak Adib and Musidik. Hello, Pak Arjan, how are you? I'm sorry, I just can join with you. Yeah, even still in the car. Just finished the meeting.
But so you have missed the presentation?
Yeah, I am sorry, but I already saw your presentation material. I think it is good, and even though we don't know the immerse tunnel can be implemented in Indonesia, I think it is very good presentation, and thank you. And also thank for the panelists from Korea, from Saman, and also from Bueni. She is the head for the Tunnel Society Association. And for the distinguished ladies and gentlemen, thank also for you all to join this webinar. And I think we will also have the next webinar in the next year. And thanks for the sponsorship, yeah, from Adimik, Saman, and Aglinas, also MRT. So thanks again. And I think if I didn't follow your presentation, but when I read from the presentation, we can identify that for the development of immersed tunnels, we need the detailed survey and also detailed risk calculation. And I think even though this immersed tunnel maybe have higher cost in compared to the bridge, I think in the environmental perspective, it will be better. And thanks again for Mr. Arjan for your presentation. I hope it will improve our knowledge in the tunnel. Yeah, not all, because now we just have the rock tunnel. Yeah, only one, and maybe in the future we will also construct some rock tunnel also for the road in the Aceh, maybe in the Sumatra also, in another part of the Sumatra. And now MRT, I think, have a project also for the tunnel for the railway. So distinguished and ladies and gentlemen, thanks again for joining this webinar, and maybe we can meet in the next session. Thank you, Mr. Arjan.
Yeah, no problem. Thanks also.
Okay, thank you. I back to Pak Adip. Thank you. Have a nice weekend, Pak Arjan.
Yes.
Yeah, see you.
Bye.
Okay.
See you.
Back to please, Pak
Okay,
Adip.
back to MC.
Okay, thank you, Pak Dedi, for your valuable perspective in closing today's session. On behalf of the organizing committee, we extend our sincere appreciation for all speakers, panelists, and participants, of course, for your valuable contributions and active engagement throughout today's session. And my this insight shared today continue to inspire collaboration and innovation in advancing immersed tunnel engineering and promoting sustainable transportation solution across the region. We wish you continued success in your professional journey. Please accept our sincere apologies for any shortcomings or unintended inconvenience during the course of this event. We truly appreciate your understanding. And before we conclude this event, we kindly invite all participants to turn on their cameras as we will take a group photo for documentation purposes.
Okay, next. Next. For the first, third page. Okay. Next, fourth page. Okay. The last page. Okay, thank you.
Okay, thank you. So we also like to extend our sincere appreciation to our sponsors, Adimix PCI Indonesia, Saman Corp, Agrinas Jaladri, and MRT Jakarta for their invaluable supports in making this event possible. And our appreciation also goes to our partners, ALSI, and the Indonesia Tunnels and Underground Infrastructure Society for their collaboration in making this event possible. Thank you once again and have a pleasant afternoon.
Okay, thank you. Have a happy New Year, Mr. Aran.
Thank you
Thank you,
all.
Mr.
Happy New Year
Arjan.
to you all
Happy
as
New
well.
Year. Merry Christmas.
Bye.
Happy New Year. Bye.
Bye.
Bye. Thank you.